Greetings, welcome to this new video about superposition theorem. Solve the problem number 3. In this video, I will demonstrate the application of the superposition method to solve a problem, and I will guide you through the step-by-step process of using superposition to solve the problem at hand. Let's consider this network consisting of 5 resistors labeled R1 through R5 as well as 2 independent sources Vs and Is. Additionally, we can observe the presence of a dependent source, especially a current-controlled voltage source. The first question is to find the current I0 through the resistor R2 using the superposition method. And the second question is to find the power supplied by the independent voltage source Vs. Let's move on to the solution. First, we begin by identifying each independent source in this circuit. This step provides a clear understanding of the source that will be analyzed separately. In this circuit, we can observe two independent sources, one independent voltage source Vs and one independent current source Is. Next, we proceed to deactivate all but one independent source in the circuit. This involves replacing the inactive voltage source with a short circuit, which means it's zero voltage, and a current source with an open circuit, which means it's zero current. Let's begin first by activating the independent current source Is and deactivating the independent voltage source Vs, which will be replaced by a short circuit. The next step is to consider the independent voltage source active and the independent current source inactive, which will be replaced by an open circuit. After completing the analysis for each independent source while treating the other as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the overall circuit's response. That means the current I0 through the resistor R2 is equal to IOA plus IOB. Let's move on now by considering only the independent current source Is active. In order to find the current IOA, we can apply the mesh analysis method. It's evident that we have three meshes. This is mesh number 1, this is mesh number 2, and this is mesh number 3. And I will consider the current I1 is the current in mesh 1, I2 is the current in mesh 2, and I3 is the current in mesh 3. All the currents are chosen in the clockwise direction. In mesh 1, we can see that I1 is equal to Is, is equal to 4 amps. Let's move on to mesh 2. By applying Kirchhoff's voltage law in mesh 2, we can write R1 I2 minus I1 plus R5 I2 minus 5 IOA plus R3 I2 minus I3 is equal to 0. By replacing the resistors with their numerical values and we continue simplifying this equation, we obtain negative 3I1 plus 6I2 minus I3 minus 5IOA is equal to 0. Let's move on to mesh 3. By applying Kirchhoff's voltage law in mesh 3, we can write R2 I3 minus I1 plus R3 I3 minus I2 plus 5 IOA plus R4 I3 is equal to 0. By replacing the resistors with their numerical values and we continue simplifying this equation, we obtain negative 5 I1 minus I2 plus 10 I3 plus 5 IOA is equal to 0. we can see here that I3 is equal to I1 minus I0. And if we replace I1 with its numerical value, we obtain I3 is equal to 4 minus I0A. Now, by substituting 1 and 4 in 3, we can write, or we can express I2 in terms of IOA. And by substituting 1, 5, and 4 in 2, we derive one equation in terms of IOA. And if we continue simplifying this equation, we obtain 104 minus 34 IOA is equal to 0. That means IOA is equal to 104 over 34 amps. Let's move on now by considering only Vs active. In order to find the current IOB, we can apply the mesh analysis method. It's evident that we have two meshes. This is mesh 1 and this is mesh 2. And I will consider I1 is the current in mesh 1 and I2 is the current in mesh 2. Both currents are chosen in the clockwise direction. Let's start first with mesh 1. By applying Kirchhoff's voltage law in mesh 1, we can write R1 I1 plus R5 I1 minus 5 IOB plus R3 I1 minus I2 is equal to 0. And if we continue simplifying this equation, we obtain 6I1 minus 5IOB minus I2 is equal to 0. And from here, we can observe that I2 is equal to negative IOB. If we replace I2 with negative IOB, we obtain 6I1 minus 4IOB is equal to 0. Let's move on now to mesh 2. By applying Kirchhoff's voltage law in mesh 2, we can write R2I2 plus R3I2 minus I1 plus 5IOB plus R4I2 minus Vs is equal to 0. And by replacing the resistors and the voltage with their numerical values, we continue simplifying this equation, we obtain 10I2 minus I1 plus 5IOB minus 20 is equal to 0. And if we replace I2 by negative IOB, we obtain negative 5 IOB minus I1 minus 20 is equal to 0. By performing now 1 plus 6 times 2, we obtain negative 34 IOB minus 120. That means IOB is equal to negative 120 over 34 amps. After completing the analysis for each independent source while treating the other as turned off, the subsequent step is to combine the results algebraically. This process enables us to determine the current IO, which given by IOA plus IOB. And if we replace IOA and IOB with their numerical values, we obtain IO is equal to negative 470.58 milliamps. Let's move on now to question B. To find the power supplied by the independent voltage source, the power is equal to Vs times the current I. We can see here in this node that I is equal to Is minus IO. We already found IO and we know Is. That means the power supplied by the independent source P is equal to Vs times 4 minus IO. If we replace IO with its numerical value, we obtain P is equal to 89.41 watt. After we finish the calculation, we conduct a simulation using SPICE in order to verify our results. Let's proceed now to the SPICE environment. Here is our network drawn in SPICE simulator. Here we consider only the independent current source IS active, and here we consider only the voltage source, the independent voltage source active, and this is our complete network. Let's move on to analysis. This say analysis, calculate nodal voltages. We can see here that IOA is equal to 3.06 amps is the same 104 over 34 amps, and IOB is equal to negative 3.53 amps is the same as negative 120 over 34, and this is the current IO through the resistor R2 is equal to negative 470.59 milliamps, is almost the same value we have done by calculation, and the power supplied by the voltage source Vs is equal to 89.41 watt, is also similar to the value we have done by calculation. After completing the circuit simulation, we can clearly observe the similarity between the simulation and the calculation results. This serves a validation of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about superposition method. Take care and bye-bye.